What I want to do this morning before you can start working on the labs is I want to start looking at, sorry, just one sec now. I want to walk through some or maybe all of these slides here, depending on what kind of progress I make. Uh, so let's do that. Now, we've been working away fine. We've been creating containers and through something called port forwarding or port mapping, we've been able to interact with the container from our host machine. And what else? We've also been able to uh, associate a part of the host's file system, kind of attach that to the Docker's file system. Using that minus V option there, if you remember yesterday, V for volume. Essentially, that's what's referred to as volume mounting. We're mounting a volume or uh, part of the host file system. We're mounting it onto the containers file system. So that's fine, and we'll come back to that briefly at the end of this set of slides. But uh, what I want to focus in on next is the whole networking part of Docker. You see, the reality is that when you develop an application and you want to deploy it using containerization, what you actually do is break the application up into what are referred to as microservices. If you've ever heard the word microservices, a microservices architecture, which is an architectural approach towards designing an overall application. And effectively, what it means is that you're breaking the application up into uh, mini sub-applications. Now, we won't get into the approaches towards fragmenting an application up into microservices. We won't get into that part at all. But once you have your microservices, each microservice is wrapped as an image, as a Docker image, and deployed as a container. Therefore, your typical application today is made up of, if it's deployed onto a containerized platform, it's made up of multiple containers, presumably that need to communicate with one another. And if they need to communicate, that means there needs to be some networking availability are provided to them. So how does Docker provide networking? Um, so well, it just does, and so we just need to look at its support. So when we talk about multi-container applications, that's another way of saying a microservices style or design for an application. So what's it saying? The power of containers, the power of containerization is realized when you decompose an application into microservices. That's fine. I've already kind of made that point. So out of the box, when you start up a Docker engine, then it immediately creates some default networks. And there are three default networks that are created, and you can find out what the defaults are if you just type this command from the CLI, Docker networks ls. So up to now, all we've been using the Docker command for is in relation to containers, but it turns out now that you can do it. You can issue a lot of Docker commands that are linked to its networking side. Just give me 1 second now. So Docker network ls, and if I do it from here, from my own command line, I'll just clear the screen, and I go Docker. Network. I'm not too sure whether it's network or networks, but let's try network. Yeah. So I get the same response nearly. There is one additional network that I have, which is this one here. And I'm using that for another purpose. So you can ignore that one. So ignoring that, then we have our three default networks, as you can see. A network has, okay, it has an ID, but it has a name and it has a driver. Now think of driver as uh, the type of network. And Docker has, I think it's about maybe 6 or 7 different types of networks. But the type of network that we are only concerned with in this module is what's referred to as a bridge type network. Um, the other two then are, we'll just briefly talk about them as well. So down here, I'm talking about the network driver or the network type. Now, if you've got a bridge type network, what that means or the consequence of creating a bridge or having a bridge network, and as we'll see, you can create other custom networks as well. So you can add to this list. Um, but and when you create another network, you have to tell Docker what type of network you want to create. In other words, what driver do you want to associate with this network? And so what we'll be doing is creating other bridge networks. So what do these bridge type networks, what do they have? Well, each of them will have a virtual kind of gateway, or technically it's kind of a virtual bridge interface associated with that network. And what this virtual bridge interface, or in short, this virtual gateway, what it will allow is for any container that's attached to that bridge network, it will give it essentially internet access. It can access um, anything outside of its own kind of local network. And also, every container that's attached to a bridge network, whether it be the default bridge network, which is this one here, or the custom bridge network that you create, every container will have its own IP address. Now, that IP address, though, is private in the sense that it's only visible within the bridge network itself. It's not accessible externally. But each container does have its own IP address, and therefore each container is individually kind of accessible to other containers on that network. Hence, they can communicate with one another because the communication is obviously going to happen down at the TCP/IP level, and TCP/IP is all about IP addresses as a way of identifying individual nodes, to use the networking term. But in our case, the nodes will be containers. Uh, so that's the beauty of this bridge type network. Each container gets its own IP address, and also the bridge network has a gateway to the outside world. The other two types, now I did say there are about 6 or 7 different types, but by default, the other two types are kind of edge cases, really. You've got a type called the none type. A none network, if you add a container to a none network, then that container really doesn't have any access to the outside world. So it's completely isolated from everything. And there may be cases where that's desirable. The host type, when you can only have one instance of the host type network on your within a Docker environment. But the thing about, if you add a container to a host Docker network, then effectively that container is similar to any other service that you might be running on the host machine. So in fact, it's that those containers will have the same IP address as the host machine itself. And now the host machine is on a global network, so the host machine, because it has an IP address, it will be accessible from anywhere, and your remote host can access it. And if you have Docker running on your host machine and you add a container to the host network, the host Docker network, then that container is effectively accessible by anybody externally. Okay, what's next? Okay, I'm just going to go through the three types, but really the only one we're kind of really interested in is the bridge network. So it turns out now that when you run a container, or when you ask Docker to create a container using the Docker run command, you have this additional option of telling it which network do you want to attach this container to. And if you don't specify any network, then by default, it's added to the bridge network, to the default bridge network. If I just go back again for a second, like it's unfortunate now that the default bridge network, which is of type bridge, its name is also bridge. Can I just get confirmation from somebody that you're seeing my screen again?
All good.
Great. So yeah, that was actually my fault now. Right. So what I was saying was, it's kind of unfortunate that the Docker people decided to give these particular names, well, this one in particular, give this name to this particular network. So when I talk about the bridge network, it's the default bridge network I'm talking about. But later on, we'll be creating our own bridge networks as well. Okay. So now it turns out that you have the option when you're running or creating a container using Docker run, you can tell the Docker daemon which network you want to add your container to. And if you don't specify any, then it will automatically add it to the default bridge network. Okay, so that's actually been happening yesterday and last week when we were running containers. Uh, okay. So if you actually wanted to add it to one of the other default networks, the network called the none network, then this is how you do it. But of course, the none network is characterized by the fact that that container, it doesn't even have an IP address, even though it's private, it doesn't have an IP address. It has no access to the outside world, so to speak, because there's no gateway available to it. So it's completely insulated. And there might be edge kind of cases where that's desirable. You know, if you've got an application that does lots of kind of number crunching, maybe um, accessing maybe the local file system, but it doesn't need any external access at all, then that's kind of that kind of scenario would suit here, but really it's very rare. So the container, okay, it is in a network space, but it doesn't have any outside access. It only has local loopback, other access. Sorry, that's okay. So like I say, it's kind of an edge case, and just the image which I got somewhere. This is your container. It doesn't have any IP address, which they normally would. The green box is your host machine. Of course, your host machine, well, more than likely, your host machine does have internet access, so it has its own Ethernet card. It has the host machine does have an IP address, but look, there's no link here between the two. Therefore, this container can't get out, so to speak. It can't get any uh, receive requests from the outside world, or it can't communicate with the outside world. Uh, the second uh, type of network is the host network, um, is the host type, and there is a default host network. Equally, you can add a container to the default host network. So let's supposing we started this container here and we started it on port 88, or sorry, we started this container and let's suppose the container is running some type of web application, okay? And the web server running inside this container is listing on port 8080. Now, because we've added this container to the host Docker network, effectively, this container, its IP address is the IP address of the host machine itself. So whenever anybody sends and maybe this host machine has a domain name as well, if it has a public IP address, then it will have a domain name. But either way, if there is a request sent to this IP address on port 8080, then that will automatically get sent to this container. So it's as if this container is a service that's running on this host, just like any other service that you might have running on a host machine. Um, there's a slight catch though when you're using Docker Desktop. Just to give you a little bit of history, right? So Docker originally was developed to run on a Linux operating system. If you wanted to run Docker on a Windows machine or a Mac machine, you have to go through a whole procedure of, first of all, installing a hypervisor software on your host machine, and then running or creating a virtual machine, a Linux virtual machine on top of that hypervisor, then installing Docker on that Linux virtual machine. And now you're there, kind of. You have now Docker installed on your Mac or Windows um, uh, hardware. Okay. Uh, but in that kind of scenario, the host is not your Mac or Windows machine. The host is the Linux virtual machine that Docker is installed on. Now, along came Docker Desktop, and we installed Docker Desktop. I've installed it on my Mac machine. You installed it on your computer. But but what's actually happening when you install the Docker Desktop is a hypervisor is installed and a Linux virtual machine is running on top of that hypervisor. The hypervisor software is called HyperKit. Okay. So in a way, if you like, if this green box here is your personal computer and you've installed Docker Desktop, what you've actually installed, if I might try and draw it like this, right? You've installed inside of this box is a hypervisor, which I'll make sort of this layer here. This is your hypervisor layer. Then on top of that, there is a Linux virtual machine. And then you've installed Docker on this Linux virtual machine. And this virtual machine, that is really the host for your Docker installation. It's not this green box here. Why am I telling you all of that? I'm telling you all of that because I cannot illustrate uh, this type of network in the particular setup that I have on my machine here, nor can you on your machine. The only way we could demonstrate this host network scenario is, for example, if we logged on to the AWS cloud, created an EC2 instance. Of course, an EC2 instance is an example of a virtual machine. Create an EC2 instance i- that is based on the Linux operating system. Then connect to that EC2 instance. That's something you would have done yourselves maybe last year in third year. Connect to that EC2 instance. Install Docker on that EC2 instance. And now you have an actual scenario where you can run a container on that Linux VM, and you could attach that container to the host network. And then whatever the IP address of that EC2 instance is, you can get at that container by using the EC2's IP address. Now, I don't know if you can visualize what I've kind of been talking about there. The upshot of all of this is, look, I cannot demonstrate the host network. I can demonstrate the other two, the none and the bridge, but I can't demonstrate host because of this whole kind of configuration here that we actually have by virtue of installing Docker through this Docker desktop application. Docker desktop was brilliant because it meant everybody could run Docker now on their Windows or Mac machine. You didn't have to have either a base Linux machine or you didn't have to have all this virtualization software installed on your Windows or Mac machine in order to get Docker running. Okay, so maybe let's just move on to bridge networks, which we can talk about and demonstrate. If you want to attach your Docker container to the default bridge network, you can do it like this. Okay, this is always the network name. Whenever you have the minus minus network option, you're specifying a network name. You're not specifying a network type here. It's a network name. And so it looks like here we want to attach this container to the network, the Docker network, whose name is bridge, and as we now know, whose type is also bridge. But if you leave this out completely, then that's what happens anyway. I mentioned that there a few moments ago. Okay, so the bridge network is the default network. And I've kind of made these points out whether networks, oh yeah, the default bridge network and any other bridge network that you create, they're all assigned a subnet IP address range. Um, each bridge network has a gateway, also referred to as a virtual bridge interface. Okay, that's what gives it access to the outside world. And this is what we're kind of visualizing here on the right. Okay, so here's my Docker container. It has its own IP address. It's assigned an IP address by Docker itself, but this IP address is only visible to other containers that are part of this bridge network. Here's Maria, our virtual bridge device, okay, or our gateway. Um, the green box is our host, and let's not get into the detail now of is this a virtual host or the real host? It's just the host, okay. The host is connected to the network presumably, so it has an Ethernet card and an IP address. By the way, also our container up here, it also gets a virtual Ethernet connection. Because if anything wants to is assigned once any uh, kind of component is assigned an IP address, then it must have an Ethernet, uh, be it virtual or real, device associated with it as well. So that is the case for our containers here now. They do have an Ethernet, a virtual Ethernet um, device associated with them, which facilitates communication. Uh, the Docker 0 there, that's the actual name for the bridge. That's for the default one anyway. That's just by the way. And so now let's supposing we've got this container. Let's supposing Is it saying anything there? Um, if it has a TCP port that it's listing on, then you do have to set up this kind of port forwarding. Uh, will I talk about that now? I won't actually. I'll just come back to that maybe in a second. Now, so what we'll do actually is let's create our own bridge networks. So how do I do that? Is that what I want to do next? Just give me a second. Yeah, I'm kind of saying it here really. You can create your own custom bridge networks. In fact, you can create other types of networks as well. So you just use this command here, docker network create, the name you want to give the new network. You can also specify a type over here, which I'm not in this case. If you don't specify a type, then Docker assumes that its type is bridge. So let's just do that. So if I go Docker network create, and I call it bridge one. If I now go, oh, I must have done it already actually. I didn't think I did that actually. Sorry, let me do that again. Oh yeah, look, it's there already actually. It's there already. Okay, well, just delete it. And we create it again. And now if you go Docker network ls, yeah, we've got our network called bridge one. Its type is bridge. Now, if we want to get some more information on the bridge one network, the way we would do that is go Docker network inspect. The inspect command, we can use that with networks. We can also use it with containers. Don't think I've shown it to you so far, but you can. So if we do Docker network inspect bridge one, and we get back a lot of information about that network. And if we kind of scroll up, you see here, um, this part here, it's telling us, look, this is the subnetwork IP address range, this part here. This is the network IP address range that Docker has assigned to this bridge network. This is the IP address of the gateway, that virtual bridge that it has created for this bridge network. And if I did the exact same, if I issued the exact same command for the default bridge is named just bridge, then we have similar stuff, I think. Do we? Yeah. Here's the configuration for the default one. It also has a subnet range, which would be different from the subnet range of the other one, and it has gateway. So, the both of my bridge networks have a similar kind of configuration, but they have different IP subnet ranges and gateway IP addresses. Okay, so that's fine. If we stick now, let's supposing I want to add some containers. Just kind of done this up here for myself. Let's supposing I want to add two containers to the bridge one network and another container to the bridge network. Now, there is an image. I can use any image I want to, but there is a useful image called BusyBox, which contains some useful kind of networking utilities built into it. So I'm going to use that BusyBox image. Uh, so I'm going to go Docker. I've already pulled down that BusyBox just for time reasons. So if I go Docker run, I run it in background mode. I'll explain the minus IT in a second. So, okay, I want to call my container box one and I want to add it to the network whose name is bridge. And here's the image, the busy box image that I want to have loaded into that container. Now, most images most images contain um, a kind of startup script associated with them. So let's say when we were using the HTTPD image yesterday, its startup script started up the Apache web server. Similarly, for the Nginx image, its startup script kicked off the Nginx web server. And that server then, those servers remained running inside the container. Now, the BusyBox image doesn't have a default startup script. So uh, if you if you try to run the create a container with the BusyBox image, it will create the container, but it will immediately exit because it doesn't have a startup script. Now, for that scenario, and there are some other images that are like that as well. For that scenario, you add on this minus IT option here. And what the minus IT means is to create an interactive shell initially within the container, and the effect of that will be to ensure that the container remains in a running state. Otherwise, we can't do anything with the container. Okay, so if I hit return here, and if I switch over just for convenience to the GUI, and in terms of containers, I have my box one, and we can see that's in a running state, so that's all good. Now, from a networking point of view, though, if I do Docker inspect, again, I said the inspect command you can use for different aspects of Docker, but you can inspect a container as well. So I want to inspect the box one container. Lots of information here, but what we're particularly interested in is uh, this networking part of the containers metadata. It's really what we're looking at here. And if we look at this part here, right, we can see, where is it? Oh, yeah. Oh, yeah, here, right? The container has an IP address. So I'm just going to grab that. And I'm just going to record it up here for myself. So 172.17.0.2, That's good. Now, if I actually go back to, if I inspect the network that this container is on, which is the bridge network, that one there, and we were told that the IP address range for that network is this 172.17 uh, 02-16. Did I get that right? Right, did I look, am I looking at the right thing now? Just give me 1 second. We bring up the box one again. I did add box one. Which one did I add it to? Yeah, I added it to the bridge. Docker inspect box one. Oh yeah, okay. 172.17.02. So that is within the address range for bridge for the default bridge network. So that's okay. Let's create box two and three. So we'll recall this command here. And now I want to add it to network called bridge one. And I'll call it box two. If I inspect box two, its IP address is this guy, 172.18.02. Let's also inspect bridge one to see what its subnet range is. Bridge one. Yeah, that looks right. The subnet range is 172.18.00/16. So this IP address here is within that range. And let's create a third one called box three. Again, we want to add it to bridge one, and we'll call it box three. Let's inspect box three. See what its IP address is. Here we go. Getting all these right now. Paste that there for ourselves. And as well, I didn't check it at the time, but you can see that this container, box three, it has access to a gateway. And if we went back and looked at the IP address of the gateway associated with bridge one, we would see that it's that same IP address. So that would kind of reconfirm to ourselves that this container is on the bridge one network. And like you're even being told it here, right? You're told. So we're looking at box three here. What this is telling us is the network that box three is attached to, bridge one. By the way, a container can be associated with more than one network. That's perfectly acceptable. We won't do that today, though. Okay, so this is what I've set up for myself. Two bridge networks called Bridge and Bridge 1, and we've got these containers on them. Now, if I exec into, let's say, any one of these two containers here, then let's say I exec into box 2, I need to prove to myself that I can access box 3 and also that I cannot access box 1 because box 1 and box 2 are not attached to a common kind of network. So let's do that. So if I go Docker exec, we saw that yesterday. So I want to exec into box 2. By the way, you will be doing all of this yourselves in next week's lab. So, and I step you through it. Docker exec box 2. Now, I have the ping command available to me. And ping is another one of these networking utilities which comes with the BusyBox image. So if I ping, let's say, google.com, see, can I connect to that external server? And it looks like I can because I'm getting responses back from it. So that's telling me that this container has access to the outside world, and that is via the, how do I stop this? Control C. Um, that communication is via the gateway or the virtual bridge that is associated with this network. In other words, if I go back to the slides, so I'm looking at the Bridge 1 network, and the Bridge 1 network is of type bridge. And, we talked about it that there's this virtual gateway that's created within any kind of bridge network, and that virtual gateway gives you access to the outside world. And we're kind of seeing that now. And that virtual gateway has its own IP address, and I just showed you what it was uh, for the gateway that's associated with Bridge 1. Okay, so Box 1 has contact with the outside world, but Box 2 has contact with the outside world. Can Box 2 kind of see Box 3? In other words, for example, can it ping it? So if I go ping again, and I give the IP address of that one, assuming I've got everything right now though. And yeah, it's pinging and it's getting a response back from box 3. So 2 and 3 can see each other. Now, if we try and ping box 1, it should not work because they're not attached to a common network. So again, let's kill that. Try and ping this guy. And it looks like it's hanging really. It's going to time out eventually, but it's not getting any response back from that IP address, and that's consistent with what we expected. Uh, so I'll interrupt it because it's not going to do anything. The other nice, so I was pinging there using IP addresses, but these IP addresses are kind of dynamically assigned to containers. Now, what you also get with a what we're going to call a custom bridge network, because bridge one was a network that we created, so hence it's a custom network, and it's a custom network of type bridge. With every custom bridge network, what you also get from a networking point of view is what's termed as um, uh, what is it called? Domain name resolution. What that means is that you can specify the domain name of a container, and Docker will resolve that name into an IP address. So what I mean by that is if I now type ping box 3, box 3 is in the same network, so I think that should work. So I'm pinging box 3, and yeah, that's working. So rather than specifying the IP address of box 3, I'm just specifying its the container's domain name. And I should have said really that a container's domain name is taken from the container's name itself. Okay, so a container's name that automatically becomes its domain name. That's the way Docker actually works. Let's interrupt that again. So yeah, so okay, we've kind of demonstrated creating our own custom networks, and we're particularly interested in custom bridge networks, and we've seen all the kind of nice networking support that's built into these bridge networks. The idea that each container gets its own IP address, therefore it's identifiable uh, by other containers on that network. And we also just saw domain name resolution going on there as well, which is a really nice feature. Now, if I maybe I might wrap up with this point now, but if I go back to yesterday and I started up the Apache web server, um, why don't we start up an Apache web server? Let's say put it inside this network here. So I'm going to create, let's say, another container. Let's call it web one. Let's call it web 4. And that's going to be running the Apache web server. So let's do that. So it's going to be Docker run -d minus name. And then I'll just recall this and doctor it a little bit. Let's add it to the network called bridge 1. We can do the port mapping, but we don't have to actually. Think I can actually leave that out. Don't need it. Let's supposing I don't want to be able to access it externally. And I've called it what? Web 4. Web 4. Well, let's call it my Web 4. Let's leave it at that. Okay. And I'll just show you something else in the Docker inspect command. Docker, sorry, network inspect. I think it will actually list all of the containers as well. If we go right up to, or does it? See this section here? It's telling us all of the containers that are on this network. Oh yeah. So it's telling us box 3 is on the network. My web 4 is on the network. And box 2 as well is on the network. So that those inspect commands can be very useful for not maybe not so much bug debugging, but seeing that your setup is as you wanted it to be. Now, so I now have a web server running inside this my web 4 container, and that web server is listing on port 80. So if I exec into any one of my busy boxes, let's go back into box 2, and if I can I do it? I can ping, I guess maybe. I'm not sure if this will work now, actually, now that I think about it. But if I ping, what do I want to ping? I want to ping my web 4. Obviously, that's going to work. Yeah, colon 80. Yeah, so I can access a particular port. Now, what I wanted to demonstrate, but in fact, I don't think it's going to work. Let's see. Is curl installed on this? No. Um, I couldn't. I think I do it with you in the lab actually. So the curl utility isn't available in BusyBox, but I could install it, and then once I've installed curl, and you can do installations like on the fly. If I installed curl on inside in this container, I would be able to curl uh, my web for colon 80, and what I would get back as a response would be the homepage for the Apache web server. Yeah. And I think you will do that in next week's lab anyway. If not, then I can demonstrate it in next week's lecture. Okay, time-wise, we've taken an hour. Uh, there is one other part of the slides, but I think I should let you try and work on the labs really. If I just go over to the labs. Now, don't know how well people have managed to finish this lab or not, but you need to you certainly should be able to do it now. In this lab here, which I also maybe want you to work on this week, is we have two containers. One container is going to be running the MongoDB database, which is a very common kind of sort of I was mentioning there at the beginning of the lecture, this idea of breaking up an overall application into multiple containers. Uh, Typically, if you've got a database as part of your application, you nearly always run a database within a container on its own. So that's what we're going to do in this lab. We're going to run the MongoDB database in a container. We also are going to use an image called Mongo Express, which is just really a web application that we can pull down from Docker Hub. And that web application uh, needs to communicate with the MongoDB server. Therefore, there needs to be a network here that they're both connected to. And we create that network as part of this lab. So you'll be working your way through that. Also, you will install a desktop application called MongoDB uh, Compass, I think it's called, which is just a desktop application for communicating with Mongo databases. But we will use it to interact with the Mongo database that's running inside in our container. And if I just go on to the next section here, the other thing that's slightly new is, so let's suppose we want to kick off the container that's running the Mongo database. So it's going to be a Docker run. And this is the image that we're pulling down from Docker Hub. Okay, we're giving the container a name. We're using port forwarding, which I do need to talk about just for a minute or two, but the port 27017, that is the default port that MongoDB uses for any for connectivity. Okay, and so we're just mapping that to the equivalent port on the host machine. And the reason we need to do that is, if I go back, is to allow an external application to talk to MongoDB. Okay, so that's why we're doing the port forwarding there. And sorry, now let's go back down to that again. The other thing that's new here is this here. The -E option, when you run, use the Docker run command, the -E option allows you to initialize environment variables that the image actually needs. Now, uh, if we looked at the Mongo image documentation on Docker Hub, and if we read it, we would find that there are a number of environment variables that you can initialize. Many of them are optional, some of them are mandatory, and I'm only using the mandatory, or I'm including the mandatory ones here. Um, if I just actually switch over to Docker Hub, and if I do a search for Mongo, okay, so this is the image that we're using, and if I do a search for, there's a section here on the environment variables that are um, available to set, and there are quite a number of them. Does it list them anywhere? Yeah, it's giving me some information. Thought there was more than that actually. Am I getting all of them there? Anyway, you don't have to read this stuff, but I'm kind of giving it to you in the lab anyway. But uh, if you want to read more detail, it's there for you. Back to here. So the net effect is this is going to start up our Mongo database server running inside a container. And similarly, when we want to start up the second container, the what I'm calling the Mongo Express image is just a web application specifically written for talking to a Mongo database, and it has kind of environment variables and some port forwarding as well. Uh, just to go back to the slides, actually, there is one slide. We already know about it really, but it's this idea of port forwarding, which I was talking about yesterday, but this kind of slide covers it for kind of formally. Port forwarding, it's also referred to as port publishing. And I'm saying here it allows a container to receive requests from remote hosts. Okay. Um, and let's see now. What port forwarding or port publishing, what it does is it takes a TCP port of the Docker host and it maps it to a containers port. And, we did that yesterday, and that's also what's going on here. Okay. So this part technically is referred to as port forwarding or port publishing. And we're taking a port of the host machine and mapping it to a port of the container. We'd have to know, of course, what ports does the container expose, or more specifically, what ports does the image that's running inside the container, what ports does it use, if any? And how do you find that out? Well, you look up again the documentation on the image if it's not your own image. So a TCP port of the Docker host is mapped to a container port. The ports can be different, so the host port can be a different number from the container port. That's fine as far as Docker is concerned. And what's happening then is, kind of was talking about this. So you've got a remote host, and it sends it's trying to create a TCP connection to the the host for your Docker daemon. And it's also that this request is going to specify the IP address or domain name of your host machine and what port on the host machine it's trying to connect to. Now, what happens then behind the scenes is that there's a special operating system process called the Docker proxy. So whenever you start up a Docker engine on your host machine, then automatically Docker creates this operating system process called Docker proxy. And what Docker proxy's role is to receive requests that are targeting a particular port of the host, take those requests and essentially forward them on to our bridge. It also does the kind of translation, because by translation I mean it needs to work out, well, what port of the ultimate destination or container up here, what port is it listening on, which may be different from the port that's associated with the host. So this guy here kind of takes care of any requests that come into the host that are targeting a particular port of the host, but where that port, that host port, has been mapped to a container port. Those types of requests are handled by this separate operating system process. You can kind of get by without knowing all of that that's going on in the background, but this image is kind of describing that flow. And so it forwards the request on to the actual bridge, and the bridge then kind of works out that it needs to pass it on to a particular container within this network. I wouldn't worry too much about the flow of communication there, but you are fourth-year students, so at a reasonable level, you need to just be aware of what's going on behind the scenes. When I talk about host here now, forget about that explanation that I was giving earlier on. The host, we needn't worry about, is the host the real host or the virtual host? Let's not get into that kind of nitty-gritty in this case. So that's port forwarding anyway, kind of slightly more formally than yesterday. And we know that the way we indicate that there is port forwarding required is by using that -p option. Port forwarding is also referred to as port publishing, as in the container is publishing one of its ports to the outside world. Okay. I would like you at this stage now to work your way through these two labs, wherever you are. You might be halfway through this one. finish that one off, and then start into this one. And I'd like you to have those two finished for this week. In next week's lab, it will be devoted to the kind of Docker networking stuff that I was demonstrating there. Even though in this lab here, we do create a network for ourselves. As in, you can see here, look, I'm doing Docker network create. Okay, I've done a lot of talking. I do invite people to ask questions, but I don't tend to get questions. But just in case, um, is there any question from anybody about what we've looked at so far? No. So I'm going to stay online until 12:15 because this is a 3-hour session. And we can communicate over Slack. And if you want to, I'll start up a Zoom session and we can just do a one-to-one Zoom session. I'll close down this Zoom session. I will remain monitoring Slack. And as I said, if you want to talk to me directly, then I'll just kick off another Zoom session and it'll be just one-to-one. Okay, I'll leave it at that. So you can start working on the labs from here on in for the rest of this session. Thanks a lot.